Hi everyone, Mrs. Jones here. In this video, we are going to look at inequality word problems. So we're going to take everything you already know about inequalities and how to solve them and apply them to some word problems specifically around geometry. So before we get started, let's review these 4 vocab words. This is how we classify angles. Hopefully these words look familiar, but if not, let's do a quick recap. So an acute angle is an angle that's between 0 and 90 degrees. So it's going to be greater than 0 degrees, but smaller than 90 degrees. So it may look like that. A right angle is probably one that you're most familiar with, and that's exactly 90 degrees. Remember, we indicate it by adding this little box in the middle of the angle. An obtuse angle is one that's greater than 90, but smaller than 180. So an obtuse angle may look like this. And then a straight angle is exactly 180 degrees, or in other words, it's a straight line. So keeping this in mind, let's look at a problem like this. It says, if the measure of an acute angle is 2x plus 4, find all values of x. Well, let's remember that we know that an acute angle has to be greater than 0 degrees, and it has to be smaller than 90 degrees. So this is then going to lead us to write 2 inequality statements. My first of which is going to tell me, well, 2x plus 4 has to be greater than 0. And my second one is going to be 2x plus 4 has to be less than 90. So now you know how to go solve both of these, right? So I would get 2x is greater than negative 4. Divide by 2, divide by 2. So one of my solutions is that x could be greater than negative 2. My other solution, I'm at 2x is less than 86. I would divide by 2, divide by 2. So my other solution, x has to be less than, 43. So any number between negative 2 and positive 43 would give me an acute angle based on this expression. So I want you to try another one. I'm going to pause the video here. Think about now, what if I gave you an obtuse angle? What are all possible values of x? So pause the video and try this one on your own. All right, and you're back. So hopefully you remember that an obtuse angle is going to be greater than 90, but smaller than 180. So what this means now is our 2 inequality statements. So 10x can be greater than 90, or 10x can be smaller than 180. Well, that's super simple to solve, right? Because we only have one step to do on each side. So that's going to leave me with x is greater than 9 and x is less than 18. So any value between 9 and 18 will satisfy this expression, creating an obtuse angle. All right. Now, what if we thought about perimeter? So remember that perimeter is when I take a I take a shape and I add up the outside, right? It's the distance around the outside of a shape. And the way that we do that is that we add up all the sides. So we here are looking at a perimeter that is at most 32 degrees. So that means that the perimeter can be no bigger than 32. So it's going to be anything less than or equal to 32 degrees, 32. So we're going to take our sides. Remember that when I have a rectangle, this is also going to be x minus 6, and then this will also be 4. So if I write an inequality statement based on this, I have 2 sides that are a value of 4, plus 2 sides that are a value of x minus 6. And all together, that's going to be less than or equal to 32. Well, let's solve this. That's going to give me 8. I'm going to have 2x minus 12. When I combine my like terms, I'll be at 2x minus 4 is less than or equal to 32. You're going to add 4 to both sides. 2x is less than or equal to, 36. Divide by 2, divide by 2. So x is less than or equal to 18. So that's one part of it. But another part that's super important to remember is that when I have a rectangle, or any shape for that matter, my side always has to exist. I can't have a side that's 0. I already know that this side is equal to 4, so I don't have to take care of that. But the fact that this side includes an x makes me realize that I need to have a second restriction here. So I need to know that this value, this side of x minus 6, has to be greater than 0. Right? I can't have a rectangle if one of the sides is less than 0. It just won't exist. So I need to think of my second restriction. So I would set up another inequality of x minus 6 is greater than 0. I would add 6 to both sides, and I know that x has to be greater than 6. So any number here that's between 6 and 18 will satisfy this rectangle to make a perimeter of no more than 32. All right, I hope that makes sense. I want you to try another one here. So pause the video and see what you can do here. All right, you're back. So the difference here was that here we're finding something that's greater than 60. So we're going to set up our inequality statement. We have two sides that are valued at 2x. Right? Remember, this will also be 2x over here. And then I have two sides that are valued at x plus 3. And I want all of that to be greater than 60. So I would solve my inequality, distributive property, combine my like terms, get my constants together, and then isolate x by dividing by 6. So here, x has to be greater than 9. The difference between this one and the last one is that I'm looking for anything that's bigger than 60. So I know that any number that's bigger than 9 will always make this side be greater than 0 and this side greater than 0. So I don't actually have to worry about this second restriction on this one like I did on the last one. Okay, now what if we think about area? Remember that area is the inside, the area that's on the inside. If I were to cover all of this with something, how much would I need? And the way that we find area, remember, is that we do length times width. So for my inequality statement here, I'm looking at something that is less than 60. So I'm going to multiply these two sides together. So I'm going to say 10 times 16 minus 2x is less than 60. Well, this is an inequality statement that I know how to solve. I'm going to be at 160 minus 20x after I do the distributive property. I'm going to subtract 160 on both sides. So I'm now at negative 20x is less than negative 100. I'm going to divide by negative 20 on both sides. And remember, when you divide by a negative, your inequality symbol is going to switch. So you end up getting x has to be greater than 5. Okay. On this, we also can think about our second statement here. We have to double check that this side is always going to be bigger than 0. So what we're going to do is we are going to take my x has to be greater than 5, and I'm going to double check that that value will always get me something that's positive. So if I pick a number that's bigger than 5, such as 6, 16 minus 2x has to be greater than 0. So I know that numbers bigger than 5 are going to work, right? A number like 6, I could do 16 minus 12. That's going to work. But I also know that I could pick a number that's bigger than 5 that would make this less than 0. So again, we need to think about a second statement here. I need to know that 16 minus 2x is always going to be bigger than 0. So I'm going to subtract 16, and I'm at negative 2x has to be greater than negative 16. I would divide by negative 2, and I would divide by negative 2. So here, I'm at x, again, I'm switching my symbol, has to be less than 8. So this tells me, if I rearrange it, I have to think of numbers that are greater than 5 and numbers that are less than 8. The numbers that are greater than 5 are going to help me get to my area that's going to be less than 60, but the numbers that are going to be less than 8 are also going to satisfy that this side will always be bigger than 0. All right, last one. I want you to try this one on your own. All right, you're back. So I have an area of has to be greater than 60, a coincidence. We keep working with the number 60 here. But here I'm going to have my inequality statement of 5 times x plus 5 is greater than 60. 5x plus 25, I'm going to subtract 25, and I'll be at 5x is greater than 35. Divide by 5, and I have x is greater than 7. Again, this is a situation where I don't have to worry about that second inequality statement because any number that's bigger than 7 here is always going to make sure that this is bigger than 0. So hopefully this all makes sense. If you have any questions, don't hesitate to ask, and good luck with your homework.